Standard forms of a polynomial. How does one write polynomials? Say a linear polynomial is written as polynomial of x is equal to ax plus b. Therefore, the equation becomes ax plus b is equal to 0. Let's take an example here. 7x is equal to minus 9 is written as 7x plus 9 is equal to 0. A quadratic polynomial is written as polynomial of x is equal to ax squared plus bx plus c. Here a is the coefficient of x squared, b is the coefficient of x, and c is a constant. And the equation becomes, therefore the equation becomes ax squared plus bx plus c is equal to 0. Second example here. 2 plus 9x squared is equal to 0 is written as 9x squared plus 0x. X is not given here, so we can write 0x as a standard form. Minus 2 is equal to 0. Lastly, let's see a cubic polynomial. Cubic polynomial. Polynomial of x is equal to ax cubed plus bx squared plus cx plus d. And the example, let's take an example here. 3x squared, 3x cubed minus 2x is equal to 19 can be written as 3x cubed plus 0x squared minus 2x, and 19 comes here, so it becomes minus 19 is equal to 0. Here we see the relationship between zeros and coefficients of a polynomial. For a linear equation, p of x is equal to ax plus b. It has 1 0 we call alpha is equal to minus b upon a, which is negative constant upon coefficient of the variable x. Let's take an example here. 2x plus 6 is equal to 0. Here the coefficient of x is 2 and the constant is plus 6. Therefore, that means a is equal to 2 and b is equal to 6. Therefore, alpha is equal to minus b upon a, which is b is 6, so minus 6 upon 2 is equal to minus 3. This is the zero called alpha. For a quadratic equation, p of x is equal to ax squared plus bx plus c. We have two zeros, as we discussed, alpha and beta. Here we see that the sum of zeros, if you add those zeros, both the zeros, alpha plus beta, one has to take minus b upon a, and if you multiply, or the product of zeros, alpha and alpha multiplied by beta, we have c upon a. Just for the information, a quadratic polynomial mostly can be expressed as p of x is equal to x squared minus the sum of zeros into x plus the product of zeros, alpha beta. Similarly, for a cubic polynomial, a cubic equation, standard form is p of x is equal to ax cubed plus bx squared plus cx plus d, alpha plus beta plus gamma, because there are three zeros here, is equal to minus b upon a minus negative coefficient of x squared and upon a coefficient of x cubed. Alpha multiplied by beta plus beta multiplied by gamma plus gamma multiplied by alpha would become c upon a, and the product of the three zeros, alpha multiplied by beta multiplied by gamma, is equal to minus d upon a. Remember that d is the constant. Division algorithm for polynomials. Let's take a simple example. When 17 is divided by 3, you get 5 as the quotient and 2 as the remainder. So we say 17 is the dividend, 3 is the divisor, 5 is the quotient, and 2 is the remainder. Take for example, for polynomial p of x is equal to 2x square plus 3x plus 1, and if it is divided by another polynomial, g of x is equal to x plus 2. Let's do that. 2x square plus 3x plus 1, x plus 2. 2x square divided by x, so it becomes 2x. Multiply 2x square, 2x by x plus 2, will become 2x square plus 4x. Subtracting this from this becomes 0, it becomes minus x plus 1. X into minus 1 is minus x, so minus x minus 2 become plus, and this will also become plus. So we'll have 0 become plus 3. Here, this is the dividend polynomial. Dividend polynomial we call p of x. This is the quotient polynomial we call q of x. This is the divisor polynomial g of x, and this is the remainder polynomial we call r of x. Therefore, p of x, the dividend polynomial, is equal to g of x, meaning the divisor polynomial, multiplied by the quotient q of x plus the remainder polynomial. If you see this here, what you will get is 17 is equal to 3 multiplied by 5 plus 2. 3 into 5 is 15 plus 2 is equal to 17. Just checking this here.